Hello, in this video we see how to compute the sum between matrices or the difference or to multiply a matrix by a constant. Let's start with the sum. Let's assume we have two matrices A and B. Both of those matrices are 2 by 2 matrices, which means that they have two rows and two columns. And we want to compute the matrix A plus B. So if we have a 2 by 2 matrix, if we have two 2 by 2 matrices A and B, the matrix A plus B is also a 2 by 2 matrix. And what we put in the different elements is the sum between the elements that are in the same position. So let's see how. For example, the first element in the first row and the first column, so the element 1, 1 of the matrix A plus B will be the result of the sum between the element 1, 1 of the matrix A and the element 1, 1 of the matrix B. The element 1, 2 of the matrix A plus B will be the sum between the element 1, 2 of the matrix A and the element 1, 2 of the matrix B. So forth and so on, and the second row becomes like this. And what we get at the end, we just have to compute the sum that we have written in all the different positions, and what we find is that A plus B is equal to the matrix 1, 1, 1, 1. That is also a 2 by 2 matrix, as we have said at the beginning. Let's see another example. We have these two matrices, A, which is 5, 1, 8, 3, and B, which is 4, 5, 2, 5. And we want to compute the matrix A plus B. So, in the element 1, 1 of the matrix A plus B, there will be the sum between the element 1, 1 of the matrix A and the element 1, 1 of the matrix B. So, 5 plus 4. In the element 1, 2 of the matrix A plus B, we will find the sum between the element 1, 2 of the matrix A and the element 1, 2 of the matrix B. So 1 plus 5. In the second row, we will find 8 plus 2 and 3 plus 5. So if we compute all the sums, what we get is that the matrix A plus B is equal to 9, 6, 10, 8. The element 1, 1 is the element 9, which is the sum between 5 and 4, which are the element 1, 1 of the matrix A and B. Okay, so we have seen how to do the sum between matrices. Now let's see how to do the difference between matrices, and let's do it with the same matrices A and B. So this time we want to compute the difference. And in the element 1, 1 of the matrix A minus B, we will find the element 1, 1 of the matrix A minus the element 1, 1 of the matrix B, so 5 minus 4. In the same way, in the element 1, 2 of the matrix A minus B, we will find the element 1 minus the element 5, so 1 minus 5. In the second row, we will find the element 8 minus 2 in position 2, 1, and the element 3 minus 5 in position 2, 2. Then we compute the differences and we find that the matrix A minus B is equal to 1 minus 4, 6 minus 2. The next operation that we want to see how to do is the multiplication of a matrix and a constant. So let's assume I have a matrix A, 5, 1, 8, 3, and a number, a constant, which is 5. So we want to compute the matrix K multiplied by A. What we have to do is that for every element of the matrix A has to be multiplied by the constant 5. So the element 1, 1 of the matrix K multiplied by A will be the element 5 multiplied by the constant 5. The element 1, 2 will be the number 1, again multiplied by the constant 5. In the same way, the element 2, 1 will be 8 multiplied by the constant 5, and the element 2, 2 will be 3 multiplied by 5. Then we do all the multiplications and we find that the matrix K multiplied by A is equal to 25, 5, 40, and 15. So when I multiply a matrix that is 2 by 2 by a constant, I also get a matrix that is 2 by 2, where every element of the initial matrix was multiplied by the constant. Now we have seen all the operations, so we can practice a little bit, and we practice with the exercise 1.3 at page 64. So in this exercise we have two matrices, A and B. These two matrices are 2 by 3 matrices, which means that they have 2 rows and 3 columns. And we have to do different operations. So the first question is find the transpose of the matrix A. So we recall that the transpose of a matrix, for in this case a 2 by 3 matrix, is a 3 by 2 matrix, where the columns of the matrix A become the rows of the matrix transpose A. So the transpose of A is this matrix here. You see that the first column of the matrix A has the number 1, 4, and now it has become the first row of its transposed. The second column, it has the number 2, 5, and has become the second row of the transposed matrix. In the same way, the third column of the matrix A, which has the number 3, 6, has become the third row of the matrix transposed A. Now, second question, we have to find the transpose of the matrix B. The matrix B is also a 2 by 3 matrix, so its transpose will be a 3 by 2 matrix. In particular, it will be this matrix where the columns of the matrix B have become the rows of the matrix transpose B. For example, the first column of the matrix B has the number 5 and 4, and now the first row of the matrix transpose B has the number 5 and 4, and so forth and so on. Now we have to compute the transpose of the matrix A. So we have already compute the transpose of the matrix A, which is this matrix here, is a 3 by 2 matrix. And now we want to compute the transpose of this matrix, which will be a 2 by 3 matrix. And in particular, it will be this matrix here, which is equal to the initial matrix. So the transpose of a matrix is equal to the initial matrix, because I am transposing 2 times, so I'm going back to the original matrix. Next question is find the transpose of the matrix K multiplied by A. So first of all, before computing the transpose, we have to compute the matrix K multiplied by A. We don't have a value for K, so what we find is that we can write K as K, and K multiplied by A will be K1, K2, K3, K4, K5, and K6, which means that I have multiplied all the elements of the matrix A by the constant K. For example, the element 1, 1 of the matrix A is 1, so I multiplied 1 by K, which is equal to, say, K1. And then, once I have the matrix K multiplied by A, I compute its transpose. So, since the matrix K multiplied by A is a 2 by 3 matrix, its transpose is a 3 by 2 matrix, where the rows of the column of the rows of the matrix K by A become the columns of the matrix K by A transposed. Now we have to find K that multiplies the transpose of A. So first we write the transpose of A, and then we multiply the transpose of A by the constant K. So we multiply every element of the matrix transpose A by the constant K. So this is the result. Next question, we have to find the sum between the transpose of A and the transpose of B. So let's write the two transpose we have already computed are those two matrices. Those are 3 by 2 matrices, and we have to compute the sum between these two matrices. And we recall that the sum will be, in every element, will be the sum of the elements of the initial matrices. So for example, in the element 1, 1, we find 1 plus 5 because the element 1, 1 of the transpose A is 1 and the element 1, 1 of transpose B is 5. In the same way, the element 1, 2 will be the sum between 4 and 4 because 4 is the element 1, 2 of the matrix transpose A and 4 is also the element 1, 2 of the matrix transpose B. And then in the next step we compute the difference, the sum, and so at the end the sum between the matrix transpose A and transpose B is a 3 by 2 matrix that has the elements 6, 8, 5, 12, 5, 7. In the next question we have to find the transpose of the matrix A plus B. So first we have to compute the matrix A plus B and then we will transpose it. So A plus B will be a 2 by 3 matrix because A and B are both 2 by 3 matrices, and in the elements we will find the sum between the elements that are in the same position. So this is what we will find. For example, the element 1, 1 is the sum 1 plus 5 because 1 is the element 1, 1 of the matrix A and 5 is the element 1, 1 of the matrix B. So if we compute all the sums, we find this matrix here, 2 by 3 matrix, that has the elements 6, 5, 5, 8, 12, 7. And then we will compute its transpose. So what the matrix A plus B is a 2 by 3 matrix, so its transpose will be a 3 by 2 matrix, where the rows of the matrix A plus B become the column of the matrix A plus B transposed. So this is the final result. Next question, we have to find A transposed minus B transposed. So again, we write the transpose of the matrix A and B. We have already computed them. And we have to compute the difference. So what we will find in every element is the difference between elements that are in the same location. So it will be something like this. For example, in the first element, the element 1, 1, we find 1 minus 5. And this is because 1 is the element 1, 1 of the matrix A and 5 is the element 1, 1 of the matrix B. And then we will compute the differences, and what we find is that the matrix A transpose minus B transposed is a 3 by 2 matrix with the elements minus 4, 0, minus 1, minus 2, 1, 5. Now we have to find the matrix A minus B transposed. So first we compute the matrix A minus B and then we transpose it. So the matrix A minus B, again, we have already seen it, we are expert by now. So it will be a matrix where in every element we will find the difference between the elements A and B that are in the same location. So it will be something like that. We compute all the differences and we find this matrix, which is a 2 by 3 matrix. So its transpose will be a 3 by 2 matrix, where the rows of the matrix A minus B become the columns of the matrix A minus B transpose. So something like this. So this was a video about difference, sum and multiplication of matrices by a constant and transposed.